In this video, we're going to talk about transforming the basic graph y equals absolute value of x. And here we have an example. It says the graph of y equals absolute value of x has been transformed. How? Okay, so this is our basic graph of y equals absolute value of x in blue. Now, how did it become the one in the orange graph? Well, we could see that it was shifted up and to the right. So that tells us that we're gonna have a horizontal shift 3 units to the right. So that means we're gonna subtract 3 units from x inside the absolute value function, right? Also, it was shifted up 4 units. That means that we're gonna add 4 units on top of absolute value function. And also you could see that this function is actually skinnier. Like the orange function is skinnier than the blue function. So it must have been multiplied. How much was it multiplied? Well, we know, since let's focus on this branch of our absolute value function. We know that it has it's a line y equals x, right? So the slope of this function is 1. And we can verify it: 1 step to the right, 1 step up, 1 step to the right, 1 step up. We end up on the function, on the line itself. Now, for this function, if we start at the vertex, we have to actually, if we go 1 step to the right, we have to go 2 steps up in order to get back to our line instead of 1. Again, 1 step to the right, 2 steps up to get back to the line. So it grows twice as fast as the blue line. Remember, the blue one has 1 step to the right, 1 step up, 1 step to the right, 1 step up. This one is 1 step to the right, 2 steps up, 1 step to the right, 2 steps up. So it grows twice as fast. So that means that our absolute value is multiplied by 2. Okay, so um, yeah, we multiply the absolute value. The absolute value is multiplied by 2 in order to stretch it by a factor of 2, and then it's moved 3 units to the right. So we add subtract 3 inside the function, and we add 4 on top because it's moved 4 units up. All right, so I hope, let me know if you guys have any questions about it. Okay, so here's a challenge now. Write an equation for the function graph. So we're not given anything, any information. Let's figure it out. So we have y equals, so the absolute value function, we need to figure out if it's stretched, if it's moved horizontally, and if it's moved vertically. Okay, so let's figure out. So our coefficient here, that's a stretch or compression. Let's see. So the function goes again twice as fast. As we go to the right once, we have to go up twice in order to get back to the function. So the stretch is going to be 2, right? What about moving? So the vertex, in the original function, the vertex is at 0, 0. Now this vertex was moved 1, 2, 3 units to the right. So inside minus 3. So that's the horizontal move. And it goes 2 units down. So minus 2 is our vertical move. So this is how we write an equation of the function by looking at its graph. Now, here's a common question for this type of problem. If we couldn't observe the stretch of the function from the graphs, could we algebraically determine it? So let's say you're looking at this graph and it's not obvious. What is the stretch of this graph? How can we determine the stretch? It says if we are unable to determine the stretch based on the width of the graph, we can solve for the stretch factor by putting in a known pair of values for x and f of x. So basically, we know the basic right, the basic structure of this equation. We're gonna have a multiplied by x minus b plus c. So and a would be a stretch factor. This is a horizontal shift and vertical shift. So we still determine the horizontal and vertical shift by looking at the vertex. Where did the point, basically the pointy part of the graph, how did it shift? We know it should be at 0, 0. So we know that the horizontal shift was 3. The vertical shift was -2. So not a problem. We put it in, right? The only unknown here now is A, right? So we're gonna take a point. So we need to determine A, but we could just grab any y value, f of x is y, right? And any x value, and put into this equation and solve for A. So for example, you're looking at the graph, you could grab 1 and this point, for example, with coordinates 1, 2. So we're gonna try this point, but we could have tried any other point on this graph. 2, 0, 3, -2, any point will work. And we're gonna, so the point that we grabbed was 1, 2. So x equals 1 and y equals 2. Plug it in, we're gonna get 2 equals a times the absolute value of 1 minus 3 minus 2, and solve for A. So let's do that. A 1 minus 3 is -2. By the way, there is a multiplication sign in between them, right? Just like with f is if this is just regular parentheses, there is a multiplication sign there. Okay, so what's the absolute value of -2? Well, it's a +2, right? So we have 2a minus 2. Now let's add 2 to both sides. We get 4 equals 2a. So a is just 2. Okay, so this is how you do it. You figure out your B and C by looking at the vertex, and then grab a point, plug in y value for f of x, plug in x value for x, and then solve for your stretch factor. Okay, so now I want you to try and write this equation by yourself. Says write the equation for the absolute value function that is horizontally shifted left 2 units and is vertically reflected and vertically shifted up 3 units. So reflected, shifted left 2 units, and shifted up 3 units. Go ahead and try it. Let me know how it goes. And I'll see you in the next video.